One of these better techniques is what we might call property testing. When we put together a Pytest, that Pytest can actually take parameters. And in Pytest, how we generate those parameters is called a fixture. So here we have a very simple function. It doesn't really do anything that interesting. Here, it just takes two values and it performs some arithmetic operation on them, and adds them together. And we could assume that if this was something more complicated, there might be a bug somewhere in here. For example, if x is equal to y, then it does something erroneous, it subtracts them. Now, I know this example is a little bit silly, but hopefully it doesn't obscure the point that we're trying to make. Hopefully it's not too distracting by how simplistic it is. When we write our test, we could say assert that 1 plus 2 is equal to, or that f of 1 and 2 is equal to 3. But that clearly does not catch the bug that we have. And we might wonder, well, how do we know how to catch that bug? Because I can write a bunch of these handwritten unit tests and never stumble across the error at all. So here, there you go. I already wrote 3 tests, and I got pretty okay coverage on this. If we do coverage, we'll discover that these 2 lines weren't executed. So that might be a hint that maybe I'm working within the same partition, but all of these are working with the same partition. So additional tests here really has no extra reward for the effort. Instead, what I could do is I could give this a fixture. And in that fixture, I could define how we determine the test values, x and y. And here, I can do something like that. If I do something like this, you can see, well, obviously, if my fixture values are 1 and 2, then nothing gets caught. If my fixture values are 1 and 1, then something does get caught. So I could extend this example just very, very slightly. What if what I do is I randomly generate my fixture values, and I'll actually do this without a seeded random number generator. So here, I'll say, let's look at our domain, and let's randomly pick an x value from -10 to +10, and a y value from -10 to +10. Now note, because we are doing a random search through this domain, well, there's a probability that we'll land on a value that is erroneous. There's a probability that we'll land on a value that is not erroneous. But the general principle might be, if we really think about it, there's enough people behind the scenes running our code, running our tests. Every time we push to a particular branch, maybe tests are triggered, that eventually this test will run, and it will run on an erroneous input, and it'll give us some indication that the input was erroneous, and then somebody can come in and say, okay, what went wrong? And you'll see here, for a domain this large, it's actually pretty hard for us to get a random input, but we eventually got a random input that did it. And so you could say, the size of the overlying domain and the quality of the search that we have will affect how quickly we can find these erroneous values. This, I think, is strictly better than what we started with, because instead of fixating on our guess for where the partitions are, we're at least performing some search through the space, so something that we don't expect might be of interest will still pop up and will still be checked. And as a consequence, we're beginning to get a little bit of predicative value, but not great, because you can see how many times you had to run this before the error made itself visible. Well, one thing that we could do is we could improve the quality of the search. And so what we're going to do is we're going to use a tool like Hypothesis. What Hypothesis allows us to do is set up, basically, hypotheses around our tests. We can specify fixtures that are not fixed values, but are generated in some fashion. And given those fixtures, we can allow Hypothesis to come in and figure out how it wants to select test values to test. Now, when we do this, Hypothesis is not going to do a completely random search. It's going to do a heuristic-aided search. And that heuristic-aided search is going to search through the space, privileging certain items that, just by the heuristics of how things go, are fairly well known to be values that are of interest, values that are going to maybe potentially cause an error. Nands, infinities, zeros, negative values. It's going to make sure that it gives you a nice distributed search so that it doesn't accidentally give you just a bunch of values from within the same partition. And so you could think that it's very easy to do that with the erroneous version of this code, but if we add the bug back into this code, let's see, hypothesis immediately picks up the error. Because instead of running this test just once, hypothesis will run this test multiple times under a fixed budget. And instead of just looking through in a completely random fashion the input domain, it is going to use some heuristics to guide that. One other thing that hypothesis tries to do is if it finds some crazy value that gives you a failing test, it'll try and do what's called test reduction. It'll try and reduce whatever input values it has to the smallest reproducible use case, which, by the way, if you're reporting this bug to somebody, they would love to see. They always want to see the smallest reproducible test case. And there's a lot of theory and a lot of work behind how we can not only effectively search through this space, but also reduce that down to something that is the smallest reproducible example, what's called shrinkage. If we take a look at hypothesis running with statistics, we can see a little bit of the details for how this works. We can see that hypothesis ran 100 tests, and it collected as many failing examples and as many invalid examples as it can, and there's even settings that indicate what our test budget is. We can indicate that we want to test this with a very large budget, with a very small budget, and you can imagine that maybe when you're doing your testing as part of your rapid development, your interactive iterative development process, you might set that budget lower because you want to just capture things that are just glaring you in the face. But when you're about to commission a new version to be released to the world, you might set that max examples up a little bit higher. That might be worth your time because maybe at that point, a minute of time is really no big deal. Whereas when, of course, you're working interactively, when you're working iteratively, a minute is a pretty loose iteration cycle. Now, when we do this with hypothesis, we can set up what we want the inputs to be, and we can even do other things to filter these inputs in ways. For example, we can set the minimum value for these. We can set the maximum value. And this, you can see, not only serves to guide the hypothesis search better, but it also serves as documentation. Because if somebody's looking at this code and they say, what could X be? What could Y be? Well, one additional supplementary source of information for them is to look at the test and to say, well, they only ever tested this from 0 to 10. That's probably what X can be. It can be an integer value from 0 to 10. In a very similar sense, we could also do a filter on this, and we could say X is always, say, an even number, and Y is always an odd number. And this is, again, something that we could put in a comment, or we could put in the doc string. But how do we make sure the doc string is up to date? Well, we'd have to use a doc test. How do we make sure the comment is up to date? Well, we would have to use something like an assert. Well, you can think that this is one additional supplementary way that we can make sure that we communicate to an end user what is going on with this code, how it's supposed to be used, and what we are considering to be correct usage of this, while also doing that in a way where if something changes, everybody is immediately made aware that we're going to be communicating something that is no longer correct because the test will start to fail. Additionally, when we think about these tests, one thing that you might be a little bit dissatisfied about is I tested adding two things in terms of adding two things. This was completely tautological. This test here was basically the same thing as testing that f of xy is equal to f of xy. And by the way, between you and me, that's not even that bad of a test because, look, this test is really easy to write, takes me no more than 1 minute, and it does check something moderately interesting that, for example, that this function is pure, there's nothing in the global state that might affect it. Now, obviously, I'm not tweaking or playing with the global state at all here, so this would have to be, for example, something that looks like this. Something that looks like this that would affect the way in which the test works. But again, very, very, very low effort. Probably don't have to chase after this much because that's a really meaningful change to how this code works if it gives you different answers if you call it twice. Very meaningful in terms of how it affects our users because you can imagine that a user in their code who writes something like this, g past f of x, f of xy like that, might say, could I just turn this into this? And if they cannot, well, your test will surface that that's not a valid transformation. And if they can, your test will affirm, oh, that's a valid transformation. So here, this is what we might call a smoke test. Where there's smoke, there's fire. Very simple test, takes no effort to write, doesn't really check that much, but if it fails immediately, it fails fast, and it tells us something really weird is happening that we didn't expect. However, beyond that, actually relying on this to test anything more than that most superficial, let's just make sure we're on the planet Earth, the ground is beneath our feet, the sun still rises on one side of the Earth and sets on the other side of the Earth, the sky is still above our heads, birds still fly in the sky, fish still swim in the ocean. Beyond those details, it doesn't really give us that much. And so we need to try and discover how we can test the output of this thing without fixating on an oracle that tells us what the output would be.